Today we are on Unit 1, Lesson 8, Radicals. Today we are going to add, subtract, multiply, divide, and simplify radicals. So these square roots are really helpful to know and just to have memorized if you don't already. The square root of 1 there is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 is 11. The square root of 144 is 12. The square root of 169 is 13. The square root of 196 is 14. And the square root of 225 is 15. So if you have those memorized, it's going to make square roots a lot easier. All right, so now let's go ahead and let's find each real root. So these come out nice and evenly here. So square root of 4, hopefully you remember, is 2, because 2 times 2 is 4. Square root of 9 is 3, because 3 times 3 is 9. The square root of 121 is 11, because 11 times 11 is 121. All right, so now these next ones don't necessarily break down evenly. So to be a nice whole number. So we're trying to find the exact answer with these. So you're going to see this terminology here. They're going to say simplify, and we want exact answers. And so what that's going to mean is that we're going to leave answer with a radical. And it's going to be a simplified radical. Okay, so square root of 24, if you were to put that on your calculator and did the square root of 24 on there, it's going to come out to be some decimal. We don't want a decimal answer. We want an exact answer. An exact answer is a non-decimal answer that we're looking for in this case here. So let's break down 24. So we have some options if you think about it. 24 times 1, we've got 2 times 12, we've got 3 times 8, or we've got 4 times 6. Now which one of those pairs, one of those you can actually find the square root of. So I'm going to pick 4 and 6, and let me show you why. The reason why I'm picking 4 and 6 here is because I can actually find the square root of 4. The square root of 4 there is 2, and then I'm left over here with the square root of 6. And if I start thinking about 6, the only thing that goes into 6 there, besides 6 and 1, which is unhelpful, is 2 and 3. And you can't find the square root of 2, and you can't find the square root of 3. So we are finished. It's just 2 square root of 6. So to see that's an exact answer, it has a radical there in the answer. It's a simplified radical. Square root of 48, let's think through that one. So what can go into 48? Well, 48 and 1, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So looking at one like that, I'm actually going to pick the 16 and 3 because I can find the square root of 16. I'm looking for the highest number in there when you're doing your factors there. For 48 there, 16 and 3 there, you want to find the highest number there that you can actually find the square root of, and 16 is the highest number in there. So square root of 16 is 4, and I'm left with the square root of 3. Right? So you may have thought something else. So maybe you thought 4 and 12. If you thought 4 and 12, you could do the square root of 4 and the square root of 12. The square root of 4 there is 2, but then you could still break down 12 as 4 and 3. So then the square root of 4 there is 2, and then I'm left there with the square root of 3. And then because I have these numbers here on the outsides here, I have to combine anything left on the outsides. So do you see how I still get this 4 square root of 3, even if I do that differently? All right, the square root of 162. So again, think about numbers that go in 162. So I just start doing that. I go 162 divided by 2 Oh, that comes out to be 81. I can find the square root of 81, so I'm going to break this down as the square root of 81 and a square root of 2. Square root of 81, there's 9, and I'm left there with a square root of 2. So let's keep going with these. We've got the square root of 500 there, so let's think about what goes into 500. So I'm going to do 500 divided by 2 is 250. 3 does not go into 500 there evenly. 4 does, it goes in 125. Now I can find the square root of 4 there, and I'm going to keep going because there might be a higher number here. So 5 times 100, yep, 5 will go into 500 there 100 times. That's a really big number because 100 there, I can take the square root of that. So I'm going to go with that one. The square root of 100 and the square root of 5. Well, the square root of 100 there is 10, and I'm left there with the square root of 5. And I can't find the square root of 5. The only two numbers that go into 5 there are 5 and 1, and they're both prime numbers. Prime numbers are ones where only the number itself and 1 go into that number, and so 5 is considered a prime number. 63, so let's break down 63. So what do you got? 63 and 1, 2 doesn't go in there evenly, 3 goes in there 21 times, 4 doesn't go in there evenly, 5, nope, 6, no, 7, yes, 7 times 9. And then we can find the square root of 9, so I'm going to pick this one. Square root of 9, square root of 7. What's the square root of 9? It's 3. Left there with the square root of 7. All right, so now we're going to go ahead and simplify these. This is over division now. So we've got the square root of 7 halves. That's the same thing as when you've got a square root over an entire fraction. That's the same thing as the square root of 7 over the square root of 2. And something to know in math is that we cannot leave a radical down, a square root or a radical down in the denominator down there. So to be able to simplify this, I would have to get rid of the square root down here in the denominator. So I'm going to multiply the numerator and denominator by the square root of 2. So if you've got two square roots, you can multiply those together, so we get the square root of 14. Same thing here, square root of 2 times square root of 2 is the square root of 4. But I can find the square root of 4, it's 2. I cannot find the square root of 14. And the only two numbers that go into 14 there are 7 and 2, and they're both prime numbers, so we cannot go any farther with that one. All right, so on to this one here. Again, the square root is over both the numerator and the denominator there, so I'm going to break this up as square root of 9 over square root of 2. I can actually find the square root of 9, it's 3. I cannot find the square root of 2, and I cannot leave the square root of 2 down the denominator. So I'm going to go ahead and multiply my numerator and denominator here by the square root of 2. And so I end up here getting 3 times the square root of 2. Down here in the denominator, square root of 2 times the square root of 2, you can multiply two square roots there together, and you get the square root of 4. But the square root of 4 there is 2. Now you always want to make sure we have it not simplified. So do you see these numbers here on the outsides here? Those are nice whole numbers there, or integers there on the outsides. 3 halves cannot be reduced, but you always want to look for that to make sure it cannot be reduced down, and that one cannot be reduced down. So, all right, so onward to this next one here. Sometimes it's helpful inside that fraction there, instead of doing the square root of 3, square root of 18 this time, I'm going to look at 3/18 and think, oh, that can be reduced down. That's just a fraction. So sometimes it's helpful to pull it apart and say the square root of 3 over the square root of 18. And since the whole thing is underneath the square root, it might be helpful this time just to reduce it down. So what goes into 3 that also goes into 18? 3 goes into 3 there once, and 3 goes into 18 there 6 times. So all I did was reduce down that fraction, and now I'm going to go ahead and take square root of 1, square root of 6, since the square root is above those. So square root of 1 there is 1. Cannot find the square root of 6. So cannot leave a square root of 6 down in the denominator, so I'm going to multiply the numerator and denominator here by a square root of 6. So we end up getting the square root of 6 over the square root of 36. And the square root of 36 down there in the denominator is 6. And I'm left there with the square root of 6 up there in the numerator. So we cannot reduce that down. The numerator up there is underneath the square root. The denominator is just a plain square root. So there's not, it's just a 6 down there. So there's not a square root down there. So that one cannot be reduced down. They'd have to be like terms to reduce them down. They'd both have to be underneath the square root or both outside the square root. All right, so our next one here, we've got the square root of 4 over 3x. And again, kind of looking at the last one, can I reduce that down, that fraction? No. So let's go ahead and let's take the square root of the numerator, square root of the denominator, separate that. Square root of 4 there, can we find that? Yes, it's 2. And then down here, still square root of 3x. Cannot leave anything in the square root in the denominator down there, so I'm going to multiply the numerator and denominator by the square root of 3x. So we get 2 times the square root of 3x. 3x times 3x is the square root of 9x squared. So what is the square root of 9x squared? Where the square root there of 9 is 3. And a nice little trick here with variables and their powers there, you can think about inside here you've got a 2 in here. So you can take that yellow 2 there and divide it by that green 2 out there. So for the x there, it's just 2 divided by 2, the one on the inside divided by the one on the outside. We don't write that 2 on the outside of a square root, but that's what it means when you've got a square root. So 2 divided by 2 there is 1, so you get x to the first, or just x. Otherwise, you just know that the square root of x squared there is x, because x times x is x squared. So however you want to think about that. Just an easy little trick. All right, and then down here, we have, you can't reduce down x over 3 there inside the square root there, so we're going to separate it, square root of x, square root of 3. I have to get rid of the square root of 3 down here in the denominator, so I'm going to multiply by the square root of 3. Square root of x times square root of 3 is a square root of 3x. Square root of 3 times the square root of 3 is a square root of 9. What is the square root of 9? It's 3. So we get the square root of 3x all over 3. And make sure when you're writing this square root here and it's over more than one term there, to make sure that if it's supposed to be underneath the square root, that it's extended over there so it doesn't, nobody has any doubts about what you mean by the square root. All right, so we just worked on division and now we're on multiplication. So looking at one like this, we've got the square root of 9 and we've got the square root of 36. We already know what the square root of 9 there is. It's 3. The square root of 36 is 6. So now I can just multiply those together there and I get 18. All right. Our next problem there, letter L, there's square root of 3 times the square root of 2. You can't find the square root of 3, you can't find the square root of 2, so now I just multiply the 2 back together, and we get the square root of 6. And we can't do anything with that one if you think about it. And what goes into 6 there is just 3 and 2, and 3 is prime because the only numbers that go in 3 are the numbers off 3 and then 1, and 2 is also prime because the only numbers that go into 2 are 2 and 1. So that just tells you cannot find the square root of that any farther. And you can't break it down any farther. All right, square root of 12 and square root of 18. Well, the square root of 12 there can be broken down as square root of 4 and square root of 3. 18, again, you're trying to think about numbers that go in there that you actually can find the square root of. You don't want to pick 6 and 3, so let's pick 9 and 2 because I can find the square root of 9. So square root of 4 is 2, square root of 9 is 3, Cannot find the square root of 2. All right, so now let's go ahead and let's combine the like terms. So these numbers, these integers here on the outside can be combined. 2 times 3, there's 6. And then we can combine these two square roots. So 3 times 2 is 6, but it's underneath the square root that we have the square root of 6. So we simply there get 6 times the square root of 6. On to addition. So something to know about when you're adding values here with radicals in there, you want to think about combining like terms. So let me write that over here. Think, combine like terms. So for an example, 5x plus 2x equals 7x. So if you've got 4 square root of 5 plus 3 square root of 5, both of them it's kind of like 4x plus 3x. That would give you 7x, but in this case it's 7 square root of 5. Square root of 80, again, think about breaking it down. So you might want to come over here and list down your options here, like 40 times 2, 4 times 20, 5 times 16. I think that might be the highest I can go here. And then 10 times 8, or 8 times 10. I'm looking at this one because I can find the square root of 16. So I'm going to break down 80 there as a square root of 16 and a square root of 5. 45, that's just 9 times 5, and I can find the square root of 9. And so the square root of 16 there is 4. The square root of 9 is 3. And just think about that. You've got 4x plus 3x, and I'm calling the square root of 5 there x. So 4x plus 3x is 7x, which is the same thing as 7 square root of 5. All right, what about this one down here? Well, now we put in a variable into this one here. So I'm just going to separate them in here. 2 times x squared plus, break down 8. What goes in 8? 4 times 2. So in this case here, cannot find the square root of 2. But I could find the square root of x squared. Square root of x squared is x. Remember, because x times x is x squared. And then plus, square root of 4 is 2. And I'm left here with the square root of 2. So those two are like terms there. We have both square root of 2 and the square root of 2 there in common. So what we can do here is we can pull out the GCF of the square root of 2. And then what's left on the outsides there? X plus 2. All right, and so let's have some practice here with some variables and find the square roots of those. So I'm going to pull these apart here. I'm going to say the square root of 16, the square root of x to the fourth, and the square root of y. Well, we can find the square root of 16 there, that's 4. Remember when we have variables, if you don't know what times what gives you x to the fourth there, and it's the same thing being there twice, a trick to doing this is to go ahead and do 4 divided by 2. What's on the inside divided by that little 2 for the square root out there on the outside. So 4 divided by 2, there's 2. So this becomes x to the second. And then we still have, you cannot find the square root of y there because it's a single y. There's not 2 of anything in there of the same thing. So that is our final answer. Let's try another one like that. We've got break down 8. It'd be 4 and 2. Break down x to the fifth. The thing about square rooting here of variables is that when you do square roots, it has to be divisible by 2. So in order for us to do that, we want to have x to the 4th or x to the 6th, not these x to the 5th or y to the 3rds there. Those are odd powers. We need even ones. So you're going to have to drop down one power. So you're going to have to change this into x to the 4th and x to the 1st. Because when you add them together, you get 5. And same thing with your y's here. To drop it down by a power, which is y squared. And then you still have a y to the 1st there left. All right. So the square root of 4 there is 2. The single ones we're going to leave inside the square root over here. So you've got a single 2, so he's going to go in the square root over here. The square root of x to the 4th, remember, is like a little 2 there. So 4 divided by 2 there is 2. So you get x squared. You've got a single x to the 1st underneath the square root up here. So the x is going to come over here and go in the square root. And then we're coming over here to look at the y's now. Y is second, the square root of that. If you can just do 2 divided by 2 there, which is 1, so you just get a y the 1st. And then you still have a single y underneath the square root there. So your final answer looks like this: 2x squared y times the square root of 2xy. So our learning targets there, I can add and subtract radicals, I can multiply and divide radicals, I can simplify radicals.